Okay, so here we have a picture of the man himself, Pythagoras. So Pythagoras was born around 495 BC, so quite a long time ago. And he is a super famous mathematician, but he's most famous for his work on this shape here, which obviously is a prism. But he focused himself on the faces of this shape here. He focused himself specifically on right angle triangles. So whenever you hear about Pythagoras, you must think of a right angle triangle. Nothing else. No scaling triangle, no isosceles triangle, no equilateral triangle. None of those work. When we think of Pythagoras, we have to think of a right angle triangle. And he came up with basically an idea that worked for every single right angle triangle you could ever draw. And his idea was that if you squared the longest side, now when you look at a triangle here, you might say to me, Miss, what is actually the longest side? And this is your big clue. Do you see this right angle? The right angle always is opposite the longest side. So there's my right angle, which means this side here must be the longest side. And these other two sides, it didn't really matter what we called those. It was just really important that we figured out the longest side. So he figured out that if he called the longest side C, okay, and if he called the other two sides, so it doesn't matter what we call those, he called them A and B, he figured out that if you squared the longest side, it would always, no matter what, be equal to the other sides added together. Now, like everything in maths, when we see it written in theory, it's a lot easier to give an example and to see how that works. Okay, so here I have a right angle triangle and I'm given the lengths of each of the sides. So this one is 3, this one is 4, and this one is 5. Pythagoras' theorem, and this is in your log tables, it states that c squared equals a squared plus b squared. Now remember what all of these stand for. C squared always equals the longest side. Now remember I showed you a trick about how to find the longest side. I said you find the right angle and you always say what's opposite it. So if we draw the line right opposite that, we will get 5. So I'm going to call 5 C. And then A and B, it doesn't matter here because we're adding A and B, and because of the commutative law, that will always work. So I've called that one A and that one B. So let's see if that's right. Let's see if his theorem works. So C squared would be 5 squared equals A squared plus B squared. So that would be 3 squared plus 4 squared. 5 squared equals 25, and 3 squared gives me 9 plus 16, which does give me 25. So 25 equals 25. So his theorem is true. Okay, so he went on and proved this theorem, and in geometry you'll watch how he actually proved it. But this lesson today is all about using this theorem to solve questions. So in example 2, we're given a right angle triangle. And we're given two sides, but we don't know what the value of this side is. So when I see a right angle triangle, I say to myself, well, no matter what, Pythagoras' theorem works, which means c squared has to be equal to a squared plus b squared. So step 1, write down your formula. And step 2, fill in what you know. So we know that the c here always stands for the longest side. So let's just make sure we write that. So the c squared always stands for the longest side. Now, remember the longest side is always opposite the right angle. So I find my right angle and then I draw my arrow right across from it. And so I get that 13 is C. And remember I said A and B doesn't matter. So once you get your C right, the rest of it is okay. So our formula is c squared is equal to a squared plus b squared. Step 2, fill in what we know. We now know c is 13, so that's now going to be 13 squared, okay, equals a squared, and a we have is x squared, plus b, which we have is 9. So 9 squared. Okay, so at this point what we're going to do is you can tell me, like, so obviously I want to find out what x is. So theoretically I want x on one side, everything else on the other. What I'm going to do first though is I'm going to work out these just to make these a little bit easier. So 13 squared, if I type that into my calculator, I get 169 equals x squared plus 9 nines are 81. And I want x's to one side, numbers to the other. So I'm going to minus 81 on both sides. And that will cancel. And on this side I will have 169 minus 81, which gives me 88 equals x squared. Now, 88 equals x squared. I don't want to find x squared. Never wanted to find x squared. I wanted to find what x was. So how do I get rid of a square? Well, hopefully you're saying it with me, and if not, it might be something new for you today. You get rid of a square by square rooting both sides. Because what you'll find is the square root and the square, they cancel, and that gives you x equals. And then root 88, you're going to type that into your calculator and see what you get. And I'm getting 9.38. Okay, so we use Pythagoras Theorem when we're given a right angle triangle and we need to find the third side. Now, if you're doing higher level for your junior cert, I want you to have a look at this question. If you're doing ordinary level, you can just press pause on this video now, and that's all the work that I need you to do. You can move on to the next activity. So for higher level students, this was a question that came up. Let me check the year. I think it was 2019, the exam paper. And it said, using the diagram below, shows a triangle with the biggest area. Work out the area of this triangle. So they asked us to find the area of a triangle. Now, we learned back in second year that for area of a triangle, our formula is base times perpendicular height all over 2. Okay? Now, the base of this triangle is quite easy there, isn't it? The base is 10. But the perpendicular height, remember perpendicular lines, they meet at complete 90-degree angles. And so the perpendicular height of this triangle would be there. But we're not actually given that height. So what you needed to do in this question is you needed to say to yourself, okay, well, if I had the perpendicular height here, I'd have created two 90-degree angles. And then you should have been able to, or we would have been hoping you would have been able to zoom in and see, all right, this is a right angle triangle. This is a right angle triangle. And I know that the length from here to here is 8. And, well, I know the whole thing of this base is 10. So what would the base be here? It would be 5. And so if you needed to find the height of the triangle, you could call it x, and you could do Pythagoras' theorem. So let's do that then. So remember, with the new triangle that you've drawn, it's super important that we label correctly. So remember, opposite the right angle is going to be your C, and A and B doesn't matter. So Pythagoras' theorem is c squared equals a squared plus b squared, which would be 8 squared equals x squared plus 5 squared. Now, taking our time, 8 squared, 8 eighths is 64, equals x squared plus 25. And then we might minus 25 on both sides. And we're going to get a cancelling out there, and we'll get x squared equals. So what is 64 minus 25? That gives me 39. So remember now, I want the square root of that, okay? So the square root of 39. And to get rid of a square, we square root both sides. And I'm getting x equals the square root of 39. If you type that into calculator, 6.24. Now I know this question said give our answer in thirds, but not today. We're just going to focus on getting the right answer. So I've now got x is equal to 6.24. So I'm going back now to the big triangle. I knew that this was 10. I knew that this was 8. I knew that this was 8. And I'm actually now after finding the perpendicular height, which is 6.24. And now I'm going to find the area of that triangle, which is base times perpendicular height all over 2. So my base is going to be 10. So it's 10 times 6.24 all over 2. And if I type that into my calculator, I'm going to get 31.2 centimeters. And remember, this is area, so it's squared. So you can see here how in this question, it never gave us a right angle triangle. We had to create one in order to solve. So that's a little bit trickier, but I think it's good to have both examples in your copybooks now. So you're ready for activity 1 now as well.